All right, guys, so forgive me, in the last video, I did not apply our lessons on storage and memory keywords to solving the problem at hand. As you guys know, today is the new year and yesterday was New Year's Eve. So I had to cut it short. So I will do so now and then move on to voting system requirements. Okay, so based on the last couple of lessons, the question becomes, so what keyword am I going to put on in here? Am I going to put on storage or am I going to put on memory? So I said in the previous video that it had to be either storage or memory, but in this case, it's more clear cut, and here's why. So I'm creating this brand new request object here, okay? And when I create a variable like this, it automatically gets created in memory because these are our storage variables here at the top. See, all these are our storage variables. There's nothing inside of here that says to hold a single request at a time. So this key value pair inside of request here are all in memory, okay? Or it creates a new request in memory. Because that request has been created in memory, the variable new request actually points, or it can't point to a version of this in storage because it doesn't exist in storage. So all it can do is reference this as memory. And when I add it in, I'll add it in now, you see that the error goes away and my campaign is back and I can work with it. Okay, and I can prove it by replacing that storage, that memory with storage, and you see that there's still an error there, okay? And it says, the error message says type struct campaign.request memory is not convertible, or it's not implicitly convertible to be expected type struct, and so on and so on. So it's saying that it's a memory value and it can't be turned into a storage value, okay? So that right there tells you as well. All right, so I definitely need to have memory here. And so the error goes away, and so we're back in business. All right, so now I'm ready to move on to the approve request function that I'm going to be implementing. Approve request is what a contributor would call whenever they want to approve or disapprove a given request. We need to be aware of some things as we start to lay out our voting system. Now, I want to lay out two big requirements for my voting system. It may seem obvious, but I want to ensure that we're on the same page here. So I'm going to pull up, I have a couple of diagrams here. So let's pull up the first one. All right, so requirement number one, we should be able to ensure that that a single contributor cannot vote multiple times on a single spending request. So we see that Bill voted one time with yes, Jane voted with yes one time, Alex voted with a yes one time, but Amanda is trying to vote no 3 times on the same request here. We absolutely want to avoid this behavior. A contributor should only be able to vote one single time on any given request, okay? Now, on to requirement number 2. So requirement number 2 says that we need to ensure whatever voting system is resilient, even if we have thousands of contributors or approvers tied to it. So as a practical example, let me do this. I'm gonna head over to Chrome and I'm gonna look at Kickstarter. What I'm gonna do is I'm gonna go into a random campaign, get insanely creative gifts, photos, and videos. Okay, let's pull that one up. Okay, so this is an arbitrary campaign that I just pulled up on Kickstarter, and you see it has 4,550 backers, okay? And so if we're going to use Solidity and Ethereum to manage these campaigns, then it definitely has to have the ability to work with at least this many backers. So somewhere at least in the thousands. So these two requirements are going to influence how we place the design logic inside of my approval request function, okay, inside of here. So now that we understand these two big requirements, in a subsequent video, I'm going to offer one possible design to meet these requirements. So I will see you then.